Good morning, this is Phil Thomas at New Era Systems. Today I want to do a couple of different things. As you can see on the bench, we have a 100 watt Comtech KU band BUC. Recently I received two of these. One of them was bad. It wouldn't go up beyond about 40 watts. So I looked at the Comtech M&C program that's downloadable from Comtech, and I could see, looking at the FET output, that several of them were bad. A very easy way to diagnose a problem with that BUC. This BUC I've got on the bench I had running yesterday, and it goes all the way up to 100 watts without a problem. But I thought it was still a good opportunity to look at the Comtech program and see exactly what it does. The cables that I'm going to use to connect this BUC are on the left, the power cable, a simple 3-pin. I'm using 220 volt AC today. The one in the middle is the signal cable that I'm feeding from my frequency generator. And so I'm going to put in an L-band signal, in fact a couple of different L-band signals, and check the output of the amplifier. This is not going to be one of those long, detailed step-by-step tests to see where saturation is. We did that about a year ago. A friend, Bart Leica, did it, and it's also on our website. And the cable on the far right is the M&C cable. Even though it has multiple pins, only 3 of them are ever used, at least for this session of the testing. Now I'm going to start to connect everything and turn it on. Be back in a couple of minutes. The standard procedure for testing any amplifier with RF output is to make sure that you've got a dummy load on the back. The dummy load absorbs the output that would normally go to an antenna feed, but of course we don't have an antenna inside the shop, and so we route it to the dummy load, and that will prevent any stray radiation from wandering around the shop and affecting everyone in here, including me. The item in the middle with those 3 connectors on it is a crossguide coupler. It's more exotic than we normally use because I wanted to talk about that in a separate video. But for the moment, I simply use it to connect to the power meter so that I can accurately test the output of this block-up converter. And I'm going to connect the power head of the power meter directly to one of those output ports. Now this is the Comtech, they call it the RF control. You can rename it to anything you want, but that's what it looks like on the website. So I'm going to create a new device connection. It's going to be on COM1. Baud rate, as you can see, is 9600. So I'm going to test connection. Everything should be set up correctly. I've got that cable from the M&C cable from the amplifier connected to the COM port on the back of this old Windows computer. The old Windows computers often work better in this respect because all the new computers have given up using serial ports. So we've still hung on to one of these old ones, and it's very useful. So I'm going to test connection, and device connected successfully. Okay, that's a good start. So I'm going to go to Find Device. And it's going to search for an SPOD or HPOD. In this particular case, we know that we have HPOD 100 watt. Okay, we're starting to look at the diagnostics. It's not turned on and doing anything yet, so there's nothing that we're going to see at this stage other than it is online, and when we start to bring up some power, we should be able to see the power on here. Now I've made a couple of setup changes. The frequency generator is generating 1200 megahertz, 1.2 gig. Now even though this is a KU band amplifier, it expects L-band input, and L-band input will range from 1200 up to 1700 in this case, and that represents from 14 to 14.5 gigahertz. In other words, the basic KU band frequency. And I've set up the spectrum analyzer to confirm that it's reading 14 gig from the output of this amplifier. My input level is minus 30 dB from the frequency generator, and that's showing 16 watts on the power meter. Although it's not identical to the output shown on the M&C program, it's pretty close. And don't forget, Comtech are measuring the output from a different place than we are. We're going right on the back on the output flange. I don't know where they measure it from, but somewhere inside. Anyway, it's close enough. It's showing 17.8 watts. Now I'm going to look more information. Configuration. At this particular stage, if I wanted, I could add attenuation to this. In some cases, the input power is probably higher than is warranted for the necessary output, and so you can add attenuation right here. Also on this screen at the bottom, there's a confirmation again of the forward RF power, shown both in dBm, 42.5, and also in watts, 17.8. We have the ability here to mute the output. We have the ability here to turn the amplifier on and off. And I can confirm that on the power meter, as well as on the output from the M&C. It's showing basically 0.1 forward watts now. I'm going to turn it back on, because I want to look at something else. Okay, we're back up to power again. In this particular case, it's showing 15.8, and if I look at my power meter, it's showing about 15. So again, we're pretty close. These amplifiers work very well in a one-for-one redundancy mode. The redundancy is pretty well built into them. They have to be cabled from amplifier to amplifier, and this is where you set it up. In this particular case, we don't have a second one on the bench, so we can't really do very much with this. Now this is where we can see in detail how this amplifier is performing. I mentioned earlier that we had a previous amplifier in here that was really giving no decent output at all. And to find the reason, we looked at the FETs. Now, field effect transistors, and these are what provide the final output. If any of these are defective, you're not going to get up to the design output from these. And in the other amplifier, we started to look down at the later stages. I think it was from about 11 on to 23, and we found several in here that had, instead of putting out amps, they were putting out a fraction of an amp. In other words, they were pretty well shorted out. And that was a very clear indication that that other amplifier needs to go back to Comtech EF Data for complete repair and refurbishing. Not cheap, it costs us around $3,000 to do that, but it's worth it because when the amplifier comes back, it's as good as new. They do a very good job at Comtech EF Data on the repair department. Now I'm going to gradually bring up the power on this to where I think it's going to top out probably somewhere just below 100 watts. Now I'm gradually increasing 1 dBm at a time. So I've gone very easily up to 90. Now I'm going to go up to by a fraction of a dBm. It's currently minus 21.3. I'm going to take it up to minus 21.2. And although it's still increasing, I think we're getting close to the maximum. We should be. It's a 100 watt amplifier. And although the 100 watts is something of an estimate, it's normally pretty close. It can be a little higher, a little lower. They call it an average. So there it is. It's showing forward RF power of 100 watts on there. And the power meter is also showing almost 100 watts, 96.2 watts. So that's it. That's as far as I'm going to go with this particular test today. Oh, one final look at the spectrum analyzer, because although output is important, stability is also important. And you don't want to see the RF wandering. And there it is, shown at 14 gigahertz, right in the center of the map. So everything about this 100 watt KU band BUC is excellent. And now we're going to pack it up, put it back on the shelf, and wait for a new owner. That's all for today.